LED blink project. So first we're going to start off by the materials we need to use. We need an Arduino Uno board. There's different types of boards, so I'd recommend using Arduino Uno, the most popular one. And then 2 jumper wires, the color doesn't matter. 1 breadboard, the size doesn't matter. This one's long, but you can also have a short one. 1 LED, the color of the LED does not also matter. And then 1 wire to connect from your Arduino board to your computer. Okay, so first we're going to start off by our connections. So we have to put 1 wire here on G and D. Why, you ask? Because G and D is basically ground. It's stood for ground. And ground is always for negative charges. What negative charges you're going to say? Well, see this blue negative sign? Well, all the way down this whole line is negative charges. So an LED has 2 sides, which I'll just show now. One side is longer than the other. So the longer side is the positive side, which is called anode. Right here. So this line is called anode, which is the positive side of the LED. And this side is called the cathode, which is the negative side of the LED. So now, do you see these 2 wires? So we know that G and D, which stands for ground, always is connected for negative charges, which is why it is connected here, because the shorter side here is going to be connected this way. So that way it'll be next to the brown wire to take in negative charges from the shorter side. So it'll be connected right here like that. So if you see, this is the shorter side, the one on your right. So you have to kind of change the shape here because it's not straight, so just put it in more. And then now you see this red wire. The red wire is next to the positive side, which is probably because it's giving in the LED positive charges. And where is it connected? It's connected on 7. So the thing for the anode, which is the positive charges, or the positive side, is that it can be connected to any of these numbers here, but it can't be connected to G and D or A, R, E, F. So it can only be connected to all these numbers until 13, but it can't be connected to G and D because G and D is only for negative charges. Okay, so now we put this brown wire on this spot right there. I'll just change a little bit so it'll be clear to see. Okay, so now we put this brown wire here and the red wire right there. Okay, so let me just turn it on this way. So now you see that the brown wire is on D, and then the cathode, which is the shorter side of the LED, is on E. The longer side of the LED, which is called the anode, is on F. And okay, so we know that the brown side is on D, which is next to the shorter side of the LED, which is called the cathode, which is on E. And the longer side of the LED, which is called the anode, is on F, and then the red wire is on G. So one thing to know is that this whole line, so J, I, H, G, F, all contain the same amount of energy. So the whole positive charges from the red wire, which comes from 7 energy that's being transferred here, is going to be in this whole line. That's why the LED will start getting positive charges, because the LED is in that line. And the negative charges, which is on G and D, is getting transferred to this line, which is also the same thing. This whole line will have the same negative charge, so that's why this negative charge goes here. When both charges go on this LED, the LED will start lighting up and start blinking. We're going to be starting our code. First, we do the connections for the LED to blink on the breadboard. Now it's time for our code. So let me put full screen, and I'm going to explain step by step all this code that you need to know. So first, we start with line number 1, define LED pin 7, and then we go all the way down to line number 12. But before that, you need to do a few things. So you download the Arduino app by just searching in Google Chrome Arduino, and then what you do is that you click, there will be one page that'll already come, like this page, that you can rename it. And then if you want to make another coding line, separate coding file, then you just press file up here and press new sketch, which is basically another file where you can write code in. So I'm going to do full screen. You also have to select your board here, like Arduino Uno. There's a bunch of other boards. So just press Arduino Uno. I already did everything, so I think you just have to press your Arduino board, then you're good to start coding. And this check mark and then arrow means that you have to first verify your code, and if there's an error, then you have to check your code, and if there's no error, then you can upload your code, which will make the LED blink, which will we test later. So first we start with hashtag define LED pin 7. So we know that hashtag define means to explain a variable. So like LED pin 7. So the variable LED pin is equal to 7. So this variable is equal to this value. So hashtag define means that this thing equals to this thing. Okay, so now we know that we have to write always hashtag define, create our variable, which will be in this case LED pin, and we have to state its number, just like that. So since we connected our wire to number 7, we will change this number to 7. And you're like, shouldn't it be GND? Well, in this case, for this definition, we only have to state the positive charge. So just put the number that you connect it to. You can also connect it to 6, but then you have to put your wire to 6, otherwise the code will crash. Okay, now void setup and void loop is not a thing that you need to remember, because it always comes. Whenever you press new sketch or anything, it would always come. So let me show you. File, new sketch. See? Void setup and void loop already came. All of this is already here. So now we're going to see why. So when they're already here, that means it's called bare minimum, which makes them here. So something called bare minimum makes void setup and void loop automatically be in Arduino Uno, which is part of communication and what needs to be there and what not needs to be there. Okay, so now we're going to listen to this code. So first we start with void setup, which is basically initializing your code. We have to state what is an output, what's an input, so the code knows what will blink, what will not blink. So right now we wrote pin mode 12 is the output. But what do you mean pin mode 12? Well, this part of the code is actually wrong, if you can realize. Do you see what's wrong? Try to think. I'll give you 5 seconds. Okay, so now your 5 seconds are over. So the thing is that 12, we didn't put any wire on 12, which means it's supposed to be on 7, because we're going to say that the 7 is the output. Pin mode 12, 7 is the output. So write 7 output, and then we're going to write pin mode. So why is the P lowercase and why is the M uppercase? Well, there's a way in coding that you can't write any spaces, so it's hard to see what you wrote. So there's an easier way where you write lowercase for the first letter, and with the second word you put it uppercase, so it'll be easier to look at it without because if you just put you don't know where which was the second word, so you can put this uppercase. And also you need a semicolon here, which is end of statement, like a period. When you write a sentence you need a period, but when you write code you don't need a period, but you need something to end it, that line, which is a semicolon. Void setup and void loop don't need that yet, which now we'll talk about why. So void setup, as we said, initializes what goes here and what explains what is this, that this thing is an output, this thing is an input, which mode is an output, which number is a input, and it's only going to run once. So these brackets that you see, this bracket and then this bracket, are basically when you write paragraphs you need to indent first, and then the period is the last thing. But for this, it's this line until this line is a statement. This whole statement is under void setup. So void setup basically is explain void. Whenever you write void and something after that, that means that there has to be two brackets to state where which code it is. So if you write a lot of sentences but you need to put puzzles, basically. It's like a puzzle. If you had a bunch of puzzles and you need to split them, you can put them in color order, or based on text, or based on outlining if they have a flat side. So basically this is just separating different things from other different things. So you also see this in void loop. So it's saying that void in this code, in these two brackets, this is all the code only for void loop, not for void setup. So the brackets will always be there, so you don't need to do it. But if you want to make another statement void something, void LED blink or something like that, and put more code where you're going to write different types of code, then you'll probably need to add your own brackets. But right now we won't be talking about that in this video yet, about how to create your own next void thing. So in void setup we understood what in mode 7 output meant. And now we go to void loop. Void loop is like this. So in void loop, this thing is always gonna be here, as we talked about in bare minimum. And so one thing to know, that this line here has two diagonal lines, which means it's basically nodes. In other coding, there's going to be different symbols, like in Python coding, there's a hashtag, but in Arduino coding, there's two diagonal lines that'll print your nodes. So that when you upload the code, verify and upload the code, then it won't be counted. So this whole thing will not be counted in the code. That's why it's in gray. Okay, now digital write LED pin high. What does that mean? Well, we know that digital write LED pin is our variable, which means 7 is high. And by high, it means 5 volts. What's 5 volts? What's a volt, first of all? A volt is basically amount of power, how much power there is on the Arduino board. So in the Arduino board, next to this big black box where there's a lot of microcontrollers inside it, there's something called power, and there's two numbers, 3.3V and 5V. 3.3 is 3.3 volts, and the other one is 5 volts. So high means that the LED has to be on, which contains power needed, which means you have to have 3.3 volts or either 5 volts. It can automatically choose by itself based on how much light there's going in. And so the high will basically choose that in order to turn on the LED, we need 5 volts. So turn on the LED with 5 volts. volts or 3.3 volts. And then the number 7 will get this 5 volts and 3.3 volts inside of it, like the red wire that we connected on number 7 in the Arduino board, will have this amount of power and will be transferred to the connections that we were just talking about before next to the LED. It would be transferred to the other end of it to G, which will eventually be transferred to the LED. Delay 1000 means to stop, pause, just pause. But you're saying, why is it 1000? Because in Arduino, we use milliseconds, and so this milliseconds, 1000 milliseconds is equal to 1 second. So it's going to delay for 1 second, pause for 1 second, then start again. Digital write LED pin low means that 0 volts. Volts is the amount of power, so there's no power making it light. So it's going to state, in order to do the delay 1000, we need to stop the volts. We need to stop the power getting transferred. And then delay 1000 is, again, pause for 1 second. So this whole thing is the code. So now you can just put in your wire and then you press verify. As you see, so here there's going to be something called some words here. So if when we put the check mark, it's going to say verify, and then when we put the arrow, it's going to say upload in this spot next to the Arduino Uno board, to the right of it, like after this serial plotter. In between are the Arduino Uno port and then serial plotter, and there's going to be something called verify and upload when you press them. So now we're going to zoom out a little bit. The full screen is going to look a little bit smaller. And we're going to do, so I'm going to just put it this way, and then actually this way, and then we're going to upload. It says done compiling, so when we press it, it says completing sketch, done complying, so there's no thing. But if I just, for example, put 6 here, I'm going to do it, it's going to say completion error expected before token, and it's going to state after in that, it's going to like say that there's an error. But when I put that back, verify, it says done compiling, which means you can upload your code. And when I upload my code, it would start blinking. Yeah, so the LED right now for me is blinking continuously, which I'll show later.